I'm Ernestas Berzhanskis from company Intelligent Beam Solution, and we would like to present for you today DDS-CAD solution for electrical CAD design, and it's also would like to present our partners from Data Design System, which have this, I think, very useful and efficient solution software like DDS-CAD, and which actually is for electrical, mechanical, and piping software. But one of the part is electrical and light voltage network, and yes. And today we will focus on electrical engineering, and the key message is that just how simply just to work better, faster in your work. So, and I would like to say that actually we organized two webinars. Today it will be webinar, as you can see. It's just how to speed up your existing work. And on 9th of April, we organized advanced electrical design webinar. It's where we'll speak about advanced function, and where we'll speak about beam environment, 3D environment, and benefit from that. Okay, so now I just like to ask our colleagues from Data Design System, Gertjan, to start presentation. Thank you very much. Gertjan, please.
Labas, good morning. My name is Gertjan Laurensen, and I will perform today the first webinar in a live setting of DDS-CAD. I will directly start with a live demo. We will pass some steps on initial electrical design working with DDS-CAD map. Now let me switch to the program, and we will start planning. I open the program in a ground floor plan, and within this ground floor plan I will initiate some steps based on emergency plan symbols. So let me work on escape routing in the ground floor plan. From escape routing we can easily navigate and use functions inside DDS-CAD to manipulate the drawing we would like to show. Working from that drawing, I will create a complete plot layout, and from that plot layout we will continue working on electrical parts. Now, working in DDS is working with components which are available directly from the database. So what I will do is I will say place some signs for escape routing and safety signs accordingly to the ISO 7010, which is a European norm, with basic symbols. For my fire detection, I will use some detectors, and as you can see from the database, we have an extensive range of symbols. So I will place also a detector fireware panel, and once more some escape routing, which will be done in the next step. So we have the position inserted, and we will also insert some smoke detectors. Let me see from escape plan. If we place those symbols inside the model, we're able to use a plot layout, and within this plot layout we can see the symboling rising up. So what I did is I initially point in a escape routing, which can be done with a polyline and can also be done, of course, with a broken line, depending on what you would like to show and present to the plan, which could be a traditional 2D plan, of course. Now let me search for the detector in flat mode. So we have a detector with a press button, and this could be also a symbol which is used inside DDS-CAD as an ISO symbol, and this will be presented also on the plot layout. So if I now switch to my plot layout, we can see that we initiate a complete scheme also with legends which are predefined also from the ISO norm. So the fire extinguisher can be identified and also the location inside the plan. As you can see, the manipulation of the scheme is interactive. So everything which we change on ground floor plan level will be visible immediately. Although the representation of the scheme is differently, so within my settings I changed the representation for the layers I would like to show. Now the symbols that have been placed in the model itself are symbols which only have a 2D representation, but if we now switch to electrical part, which is the main topic of this webinar, we can also place other symbols like a true fire detector, press button, or a push button detector. And now the difference between this push button detector and the symbol we showed before in the ground floor plan level is that this symbol is not only a sign. So if I identify the layer of my ground floor level, initially I put in a symbol, and right now I'm also attaching a true object. And the difference between this object and the scheme symboling is that this object is not only a 2D representation but also a 3D representation. So we actually can see the push button inside the building model which is set up. Now if I switch back to my level on 3D, we can actually see the push button placed onto the wall. So in one step we place one initial object which could be represented by a sign, which could also be represented by a true object. And this is the way that in DDS in one step not only the floor plan is designed but also the true 3D is designed. Of course for symboling it's valuable to have the schematical representation. It's also valuable to have the object representation, which allows us also to connect those kind of elements. If I continue on this from my fire detection system, which is a separate unit, we can have a fire center. So searching within the database, we will have a fire detection center. This will be placed on the entrance of the building, and as you can see the symboling is rotating accordingly to the line that I'm selecting. So if I have my straight line, the symbol will actually be rotated immediately and will be placed in here. Once again, on the 3D elements, if we look into the hallway, we can see the symbol popping up onto the wall to the corresponding location. For many objects we do have presets which allows us to place easily stepped or in easily steps our symboling. From perspective of fire detection and safety signs, I would like to place a fire exit which is also defined in the ISO 7010. But in the ISO itself, this light fixture is not just a sign in DDS, it's also a true light which can be connected into our panel, into our distribution board. So in the same step, this symbol will also be represented by a safety light for escape routing. Now if we continue connecting other elements like socket and switches, That makes sense if we have also lights available to be switched and to be connected to. So first of all, I would like to start with lamps, and lamps can be placed in different steps. If I select from my database the incandescent lamps, we can have wall-mounted and spots. And as you can see from the lamps, selecting in the database and also filtering on the database is very easy inside DDS. So I will take a lamp which will be connected to the mounting height at the ceiling. So what I mentioned before, for different objects we have different default types. Now I will place one lamp directly in the reception, in which I can say I would like to have it diagonally inserted central in the middle of this room. So seen from the reception perspective, the lamp is now placed inside the room. If I would like to make a copy of the lamp, we can go with easily steps and place the lamp 6 times in this room. Well, in the same step, we can also detect the area for this room. So the basis of this plan is the room entrance in the staff room. And instead of placing one lamp at a time, we can also use the function to place symmetrical in a surface or on a surface. So if I select my surface, then the room will be detected, and we can have a distance from objects, and we can manipulate the amount of lamps, and we can also manipulate the origin. So if we would like to have a different distance, then we can switch to manual. So DDS is proposing a setting which can be applied, and in this way we can select and say we would like to interfere the differences in the amount of lamps. So depending on the distance, we can say, well, we would like to use 1.2 meters as an offset in the Y direction. And now these lamps are placed as a group inside the room. If we switch to the 3D elements, and I will select based on my last point, I will make a selection to the lamps. We will see them as a group inside the room, and the lamp types itself are connected. So if we select the room, and can still be manipulated. So if I would like to change my offset to 1.5, we can see also in 3D that this offset is immediately responding to my changes. If I select my light fixtures, we identified initially the steps onto the ceiling. And if I now switch to my suspended ceiling, we can insert a suspended ceiling into the building model by selecting from the working mode the suspended ceiling function. If we say the suspended ceiling will be at 2.25 inside this room, we automatically insert a suspended ceiling which can be centered and depending on the different sizes of the tiles. Now switching to my electrical part, the suspended ceiling is visible inside the room, and right now we can say to all the objects, you are now on the suspended ceiling, and we can see automatically that the lamps are now connected and moved accordingly to the suspended ceiling. If I change my suspended ceiling to transparent, we can also look inside the room itself, or seen from stepping into the room. There we position the lamp fixtures flush mounted into the suspended ceiling. Of course, we can have flush mounted and wall mounted, meaning that with a wall mounted function of lamps, they will be placed on top of the suspended ceiling. Now, if we change the suspended ceiling by height, of course, the lamps will be changed automatically. Now, the lamps are positioned into the model without any intelligence based on calculations or demands coming from the room. So that is our next step, that instead of placing the manual lamps within a group or placed separately, we can also perform a light calculation. And within this light calculation, integrated within DDS, we can pick one room, and based on the demands or the requirements of the room, we can say we would like to have a 300 lux as a base element and choose the corresponding reflection factor based on the materials. Now I got a message about working levels. Let's see what we have. I will place one lamp into the room like this. Let's see on the ceiling, yes. So I will pick a room. Work level is above the light mounting level, unable to calculate, so I will pick another room, which I know for sure. So right now the message occurs that something is not possible. Of course, always in a live setting, I need to see whether I can continue working. So instead of picking the room, I'm defining myself a complete diagonal as a surface for the calculation. So the principle is the same, but instead of choosing the room, I now define my free area. So in the same steps, the minimum demand for an office could be 300 lux or could be 350 lux. Based on the same reflection factor, we can continue choosing the lamp type, and depending on the amount of light given by the lamp, the calculation will be performed automatically. So if I would like to have a different orientation with a lamp type which will give a little bit more lumen, then based on the calculation, the minimum calculation requirements, we will have the light calculation performed into this room. So not only from manual placement, but we can also directly print the complete report for this light calculation. So in the background, the report is generated, and if we open up the report, we can see that based on the reflection factor, based on the outlets of the lamp types and the applied lamps, the calculation is performed on this integrated light calculation. And this is the efficiency method. So from initial steps, this could be very useful to perform light calculation based designing on lamp fixtures. The next step from light calculation, if we would like to have a more detailed level, we have an integrated interface with Dialux, in which we can save all rooms from the model and open them in Dialux into the project. So if we look to the same room, then instead of positioning the lamps in Dialux, we will position the same lamps in Dialux as a Lumiere field, and choosing the lamp fixture which performs the layout also based on Dialux export, then we can calculate the settings in a more detailed level. So the performance and the calculation based on this Dialux calculation is more advanced than the integrated efficiency method, and we can have the information calculated saved into Dialux. And what we then can do is say that the lamp types which are identified from Dialux can be connected into DDS elements, which can be connected to the ceiling, and they can be placed directly into the room. So based on the calculations, the lamps are inserted on the corresponding location, corresponding position, and one advanced step we can take is to also import the calculated ISO lines in the background of this model. So if we open up the inserted DWG ISO lines, then we will have the file shown into the model. So let me see here. And those ISO lines are directly result from Dialux. And this can also be integrated directly into the plot layout we would like to show. So when I now create a plot layout, based on the settings, then this plot layout will be the plot layout for my lamp fixtures. I will insert a sheet, I will insert a logo with a title field, and then I can choose to have which settings I would like to insert in this plot layout. So this is my entire model, and as you can see right now, all layers are assigned and are visible. And if I would like to show a different representation, then we can easily say, instead of everything on electrical, I just want to have only my lamps, and then only the lamps will be visible after a repaint, including with the ISO lines. If I don't want to see the wall numbers, we can turn them off. If I don't want to see every other element, we can also turn them off. The plot layout can be printed to PDF. It can also be directly exported as different formats like DWG or DXF files. And in that way, we are flexible of generating our output. So for the light calculation, it's also important to have switches to be connected to the circuits for the corresponding functions of the switches. So right now I will activate the function of switches. We can identify if we would like to have a single switch or a double switch. Also the preset on heights is given for the switches as a 1.05 meters, and next to the door we will have a connection point into the wall. So very easily the same function we have on rotating. If I press the rotating function, then automatically my switch will be selected to the corresponding position like this. Placing an object is easily, and changing an object is also easy. So if I would like to do changes, I will just select one object. Or if I would like to search function, we can perform a search command like the Control F function. And if I would like to have all same products added at one step, then we can identify from the database that we would like to have universal switches changed for only this one. Now all switches inside the model will be changed accordingly. So this one was intermediate, and if I now switch back to this one, or a motion detector or a push button, all of the objects are available inside DDS. Now for the manual switches, we perform the objects, but also inside Office with presence and movement detectors, we offer a different function to insert. Instead of just a single switch, we will insert a ceiling mounted detector, and from the database we have different ranges, and connecting into the room we can already see that there is a detection area around the size of this this detector. Now if I place the detector in the center of the room and now switching to my 3D mode, then I will zoom to the room, then the detection area itself is represented by a cone in which we can see it is touching not everything of the room. So maybe we would like to have, instead of one, we would like to have two. So what I do is I copy my second present detector, and I will turn off my ISO lines to have another overview. And now looking to my render mode, we can see that the sensors are now touching the full plan or the full area of the room. And instead of the switch, the manual switch, we can also use to connect this sensor to the switching devices, and that will be done by connecting to circuits. I will now have some wall-mounted sockets So we have from the database flush mounted, wall mounted sockets. We have a double representation in horizontal as well as vertical way. So if I take in a vertical way and I will position to a default level the sockets on the same position as where my switch was located, there is a very easy way for DDS to have an object placed 30 centimeters outside of this this particular point. This switch or this socket is on the same position located here as where my switch is. So for my plan view, this will be not very clear. So what I can do is I can say to the socket, I would like to use an offset of 25 centimeters so that the symbol will be used or will be placed into a different position. So I will turn off some layers. Now looking to the 3D by applying a section as a front view of this this wall, I will give a setting of my my section, the width and also the depth of looking into the wall. So we will see the detection area also mentioned here, and we can also see the sockets here. So right now I'm looking to a front view of this particular wall, and if I identify my my section, we can see that because of the depth of looking, we also see the door on the hallway side. So if I would like to not show that and only show into the wall, then I can manipulate my section view to have a clean section representation like this. If I do any changes, so for example, I will copy a single object like this this double socket. I'll place this double socket on a different height level, for example 2.10 meters, and changing into horizontal. Then not only in this section view I can work, but also the changes are directly applied into my plan view. So either if I select one object or two objects, I can rotate them and position them at any time and look into my section. Now I have to close or to manipulate my section a little bit more, also to have an overview on the other side of the wall. So now this is one socket on one side of the wall, and this is one socket on the other side of the wall. Changing them either in 2D or in 3D will result in the corresponding information. If I activate my part text, I can also activate my mounting height. So this is the 1.20 mounting height, and this was the socket which was positioned onto the other part, the 2.10 meters. So the manipulation and the speed increasement, and also selecting only sockets which are positioned at 30 centimeters, I will use the same Ctrl F function and use as criteria the mounting height on sockets on 30 centimeters. And as you can see in the selection window, only the three sockets right now are selected which will be identified as 30 centimeter height settings, and not the other sockets. Also for navigating, if I select one of the sockets, I can use the function of zoom, and I will be forced or shown the selected socket directly into my plan view. So we have the sockets, we have the lamps, we have the switches, and now it's time to connect them. From the distribution board settings on the top, there is a main distribution board for the low voltage circuits, and the low voltage circuits are defined into this board. So the board itself will have a dimensioning and is presetted with the steps on a supply and outlet circuits. And the circuits are identified for lighting and also identified for sockets. If we have an overview of this board, we can represent the scheme of the board from the supply in, and also the circuits we define afterwards, like one-phase circuits. Handling of the circuits and changing of the circuits will be handled in the second webinar for next week, how to set up this distribution board. But right now I will use the circuits, and I will connect the circuits into my plan view. And for this I will use cable ladders and cable ducts. So when I start in the position of my distribution board, I can go starting with a cable ladder into my design or into my floor plan, and this is done by easily clicks on the corresponding heights, 2.5 meters to the end of this hallway. Later on I will also connect data sockets, and from the data sockets I will start from a distribution board, a data rack, and also using a different cable ladder route. So in some countries it's allowed to have data and low voltage cables in the same ladder. If it's not allowed, we can use different ladders for this. Now right now I'm entering also the same hallway, and when I look into this particular position, I can see that I'm crossing a cable ladder on the same height. Now one thing I can do is I can connect to the same cable ladder in which a T will be generated, but I can also use the function for the automatic clash prevention. So if I would like to go over this clash, then there will be changes in height done automatically, and we can continue this cable ladder onto the different level. Now if I connect to the end, then this will be used as a data cable tray. Selecting objects, and let's see what happens by doing the automatic clash prevention. And as you can see right now, the cable ladder automatically jumps over the 300 cable ladder for the amount of room or the space which is actually needed. So right now the plan view of this cable ladder is showing information that part of this model, especially on this cable ladder, is selected on a different mounting height. So I will put in some part text to identify for the different cable tray and for the different cable ladders, also identifying the height changes. For the next story, I would like to continue this band and make a connection as a branch off into the next room. So I will continue my cable ladder, and the band will be automatically changed from a rectangle, from a round band into a T part, which will be ended in the story above. And I will do the same thing on the band on the small. Now if I would like to have the same position, I can go to the endpoint, and within one function we can use the story above right now. I insert one band too much, so from this point I would like to have reconnected, so I will delete this part, continue my cable ladder, and as you can see also the dimension of the existing cable ladder is already given. So even if I make a mistake, I can easily go one step back and perform my connection to the next floor from this on. Now in 3D top view, we will have the cable ladder positioned into the hallway. We have a different setting on avoiding the clash inside this hallway. And we are going to connect once again this part to the opposite side of this room. Now if I activate the lamps once again, then we will start drawing cables. And start drawing cables is important not only to have the circuits identified to the corresponding objects, but we can also perform calculations for the cable length and also perform calculation on voltage drop. So from my main distribution board, I will start with a circuit, and I will identify a light circuit. So let me close the electrical scheme. So this one is opened. And from my cable distribution board, I have to close this scheme in order to draw the cables. So right now I can draw a cable. So in this sample there are already connected cables, and I will take a free circuit, circuit number 4, and draw the circuit. I don't have to give the route from my distribution board into the cable ladder. So what I can do is I can directly start from this cable ladder and say generating a trunk on the selected object. So right now we can see a purple line going all the way back to the cable ladder initially where the distribution board started, and we can now go into the wall into the direction of our switch, connecting the switch to the corresponding circuit, and then say continue this cable to the height we gave to connect to the lamps. So right now, going into the lamp, into the direction of the lamp, and truly connecting the lamp itself. So right now this lamp is connected to the main distribution board circuit 1, or main distribution board 1, circuit 4, cable 4. And we can continue the connections into our plan. So right now I'm connecting all lamps with a cable. And the thing is that not only the lamp itself is connected, but we can also see right here the total length of the cable is now added from the routing from the main distribution board into this connection of lamp light fixtures. For the light fixtures which are not connected, they will also be not added to the distribution board. So let me show you the circuit. So right now we can see that the load is based on 10 amps, which is set up into the distribution board circuit. And if I now connect this trunking to the main distribution board itself, we can see something happening into the distribution board circuit list. So right now the total length is calculated back onto the main distribution board. So this is one cable of 45 meters plus, and right now the load is related to the amount of light fixtures which are connected, so nearly 0.6 kilowatt. Now these changes will be applied, and if I continue my cable, so right now I continue the cable at the end and connecting also this lamp and this lamp, then we will see immediately in the distribution board overview that the circuit for the load is now added with the 2 extra lamps. So this is completely interactive with each other. Either the connection to the distribution board is now handled by the rectangular yellow filled symbol. Also we can see the cable, and also we can see the connections to these lamp fixtures. So this is one way of connecting all the elements. And if we now go to a plot layout for the light fixtures, we can say, well, we don't want to see anything on electrical except for the lamps and the sorting. So we don't have to show the cables if we don't want to show them, but right now if we select, for example, the circuit, so I will change some texting to be more visible in this way. So if we are doing changes into the distribution board, that my circuit number 4 will be changed to circuit number 5 for some reason, or this will be circuit 4T. The changes will be done into the plan, as we can see the circuit 4T, and they will also be applied into the plot. So based on the initial steps, do we have 1 to 8 circuits, or do we have more circuits? Then also afterwards we can manipulate very easily the circuit layout. So if I select the cable and I will take off the connection to the lamp, also the circuit of the lamp will be lost, and we do provide a function to activate all components which are not connected to be identified. So with the red circle right now, the non-connected objects will be displayed immediately. So if I drag and drop the cable back onto the lamp, it will be connected again to the corresponding circuit. So I can never miss an object which should be connected. The connections for the switches can be done in different ways. It can be done with junction boxes placed central. Right now, the cable also into the junction from the junction box into the switch could be a 3-core cable. It could also be a 2-core cable. Looking to the section view once again, we can also see the cables. We can also see the cable ladder coming in. So this is a step. As you can see right now, the cable is completely onto the cable ladder in the position where it will be connected to the switch. And if we change the value for my transparency, we can also see the exact cabling going down to the switch, going up to the lamps, and connecting throughout the model. In the same way, we perform also data connections, and I will show the data connections in the ground floor level. Deactivate some lamp fixtures. So we are working in one model, and the only decision we take is what would we like to show, or what is necessary in the plan view, which can be independently regulated by the plot layout or by the representation in the different layouts. So I will continue on the end of this cable ladder. I will go over to the opposite side, to the wall, going down to a specific point where my cable ladder will be ended. And right now this cable ladder selected is inserted into the wall. So I prepared a small space in the corner of this area. Now I would like to have the object a little bit going just in front of the wall. So if I move an object, we will not only see the object on the bend, which is now moved, but also the rest of the cable ladder is moved. So right now we will do the same step. On this particular floor, I inserted a trunking box for connecting data sockets into this floor box. And in the same way we connected the low voltage or the light circuit, we can also connect to a data rack. And in the data rack, it's also a distribution board which will have 6 outlets or 6 cables connected to the patch panel. So right now I will start from my data point. hovering above the trunking, and now I can say I would like to select the trunking on this object, and as you can see the trunk is generated into this segment. So right now I also would like to have this complete cable ladder as a trunk, so I will select the entire cable ladder, generate to a trunk, and from this point I will also connect into the distribution board. Now if we look to the opposite side, until the point where we drop down with our cable ladder, also the trunk is generated. So we can say this trunk should be connected to the other trunk. Now I will go to my endpoint here and say I would like to have at the end another node, and that node should be connected to the trunk which was in the floor. So let's see if we can work this out. Now the floor is connected with the trunk, and we can see one cable inside inside the plan view, and we can have a label entered. So right here we have one cable, right here we have a second cable, and this can be done and performed also on the opposite side of the trunking. So in the floor plan we can select a second circuit from the distribution board on the data rack. So this is a free cable. So from this object we also connect to the same trunk and connect a third cable from the third object into the floor box and also connecting to the trunk. So now the result will be that we have 3 circuits connected from the distribution board in this way, this case data rack, and now we can see that this is the cable label on this particular cable, but if we look to the trunk we can see 3 cables in total which are now set up. So if we select one of the cables, also the circuit will be selected here, and if we look to the opposite side we can also see the selected data circuit. So it's very easy to identify which cable is going to which plan. And for example, if we now move one of the sockets, then not only the cable will be extended, but we can also move the cable and say, well, we would like to have the cable connected here into the trunk, meaning that in front of this trunk, when inserting a cable label, we only have 2 cables, and just before the trunk itself we have 3 cables. So selecting the cables either in this way or selecting the cables itself, it's very easy to show into the plan view and also into the plot layout and parts list. So if we generate a part list, we will see 3 connected circuits from the data rack, resulting in nearly 125 meters of cable, and we do provide a check whether the data network cables are exceeding a maximum 90 meter range when connecting them to the cable ladders. So right now for the plan view, if I change my setting for the representation of the cables, I can also use dotted lines for cables and circuits into the floor. So right now we can see in blue the cable above the ceiling, and we can see the cabling used in the cable trunk right here, identified with a dashed line. Next step is, instead of drawing cable ladders, we can also draw cable ducts. Cable ducts can have an alignment onto the wall. So if I open up, for example, this particular floor, we can see the cable duct inserted with a socket, and this is a socket for connecting IT, and we can insert also low voltage systems. So when we insert a Cat5 cable, our CAD5 sockets, we can rotate this and place accordingly. So connecting to the same steps, we can draw with a cable, or we can also manipulate manually that this socket will be connected to data port, data rack 1, cable 4, and this one will be connected to the same data rack, but then connected to circuit 5. So either we can do it manually by applying the changes, or we can do it automatically by performing the calculation, performing the connection of the cables, and also having the length of the cables selected. So right now we connected the elements and continue the cable ladders which were rising up into this particular area. So in this area, if we identify also the connection from the ground floor below, we can start drawing the cable ladder to a specific height. So we will do the same step. Also from this one, and right now if I move a little bit up, I can continue and not connecting my cable ladder, but using the same route in which the cables will be connected above each other, or the cable ladder itself. So right now, if we switch to the 3D and selecting this particular point here, we can see that one of the cable ladders is on top of each other of the other one. So we saw cable ladder, we saw cable duct, and last part we also have conduits, and conduits can be connected using the true form, or where the cable and or the cable path is going through. So I will connect a junction box which will be set into here, and that will be ended with a junction box into the wall. And right now connecting another junction box into here, going down to a specific height for my wall socket. So the junction box in horizontal way, and this is a junction box in a different height. So if we have a double horizontal like this, then we can have this one to 0.43. Now if I switch to 3D and activate my render mode, we can see that this cable together with this wall, let's see, into the wall, this one, if I clip away the rest of the geometry, we can easily navigate into the plan. So let me turn off the suspended ceiling and activate transparency. So inside the wall we do have the conduit. In front of the conduit we do have the junction box positioned at the same height. In front of that we have the object. Now manipulating this by moving one of the junction box, we can see that the rest of the system is also changed, including the junction box. Right now those kind of changes can be applied. So the object itself for the junction box is selected, and we can also select including the junction box and use this as a copy also inside other positions. So right now I copied one of the elements, and I can continue working on my conduit, also starting from the last point, and now I would like to connect here to my cable ladder position. So changing information and moving around objects. So either if I move a bend, the rest of the pipe system will connect. So if I move this object, or if I draw another cable and a conduit, the rest will follow automatically. So right now, if I open up all floors, I will identify to have two representations of the models. So everything is now selected and visible. And if I switch to my render mode, we will have an overview of the complete building, including with all elements. And based on the layer settings, I can also have a predefinition of layer settings that will represent all my electrical parts, starting from the distribution boards with the conduits going into the model accordingly to the cable ladder. We do have a connection of the cable ladders going to one floor and the other floor, which are connected. And if we then look into the connection of the lamp fixtures, we identified from the schema also the length of the cables, the load of the cables, and we can actually use this as a one-to-one real-life relations to our plot layout. So in this way, DDS-CAD on electrical perspective, we are modeling basically from 2D perspective, but in the background we already have the 3D sessions inserted. So the link or the summary of this is, in this way we can do faster, better designing, and that was the title of this this first webinar. The next week planned webinar, we are also explaining how the different settings will be set up. At the end of this this webinar, there is time for some Q&A, question and answers. The questions and answers will be centralized into the webinar, and they will be replied in private email.
And I would like also to
Anastas, with this I would like to give you, to get back to you the word, and I would like to say thank you for showing the live setting of DDS-CAD.
Okay, thank you.